Hello, I'm Bob Matheny. I'm Mayor of Zebulon, and this is, well, the Zebulon Mayor Show. We're at Little Creek Waste Treatment Plant, and we're going to show you what's going on around here. It's a lot going on, and I think you'll find it interesting, but we'll get to that in just a few minutes. First, I wanted to talk a little bit about the meetings that we had that were not filmed for this channel. We have been working, well, 2 meetings actually now on the update of our transportation plan, and we're really not updating the plan. The conversation had to do with contracting with a consultant to help us with it, and that fee was to be $27,000. And we did agree to contract with them. They'll be coming in, meeting with us, be holding public meetings. What this plan actually talks about is future road improvements in the town, which allows developers, when they come in, know what they have to do to the highway system. So it's done in conjunction with the town, North Carolina Department of Transportation, and of course developers as we move forward. So it prevents, hopefully down the road, us having a bunch of traffic clogging up because we don't have adequate road facilities. So anyway, we'll be talking more about that as we move forward to update that plan. It's been, I think, about 12 years since we did that, so it's time to revisit that issue. One of the other issues that we've been discussing is the allowing the use of the town facility, where town hall out in front and around the building by various groups if they wanted to use that facility for events. The consensus at least is that it would only be allowed to be used by people or nonprofit groups within the town of Zebulon, but on the other hand, there's also a thought not to let anyone use it. So we have some diverse opinions on the board. If you have an opinion, I wish you'd get in touch with me or one of the commissioners and tell them what you think. But we continue to discuss that and try to decide what parameters would be used if we allow people to use the facility. So all of that's still up in the air, and the debate continues. So we'll keep you informed on that as well. We're in the process of Weaver's Pond subdivision has requested an amendment to the special use policy. Weaver's Pond is the subdivision that's up adjacent to Wakeland Elementary School, and it had been in bankruptcy. It's now been acquired by a new developer, and they're moving forward, and they requested some amendments to the special use, such as modification of the amenities. They're not wanting to do away with them, but they're wanting to change some of them. So things of that nature that we've been looking at. But that'll be coming forward fairly quickly. We received a budget update at the last meeting, a mid-year budget update, which we had requested to see where we stood financially through this year, because as you're aware, we face some real financial difficulties, as do most communities, just due to the flat economy. But we had projected to need to go into our reserve funds to the tune of about $600,000. Well, those projections are now down to about $350,000. So the good news is we're only needing to go into them for about half of what we expected. The bad news is we need to go into them at all. So, but we move forward. We're going to have a really hard upcoming budget year, and again, I'll have more for you on that later on as it progresses. Well, we're going to go out and look at the waste facility, and we'll meet you outside in just a few minutes. Okay, we're again, as I said earlier, at the Little Creek Waste Treatment Plant. Joining me now is TJ Lynch. TJ is an Assistant Public Utilities Director with the City of Raleigh. Glad to have you.
Thank you.
I'm actually on your turf while you're in Zebulon, but still.
That's right. It used to be your turf.
That's right.
Raleigh Public Utilities is now responsible for operating the wastewater treatment plant in Zebulon.
Right.
And as you can see, we're upgrading it right now.
We got a lot going on here, and just to set the stage, we're upgrading from, what is it, 1.8 to 2.2?
It's exactly 1.85 to be exact, to 2.2 million gallons per day.
Right, so we can handle that much effluent per day.
That's right.
Part of it, as we'll show later on, goes on downstream. Part of it goes to to our baseball water tank for reclaimed water.
That's right, and other water uses in the town as
right,
well. Yeah,
right.
we'll use it for irrigation. We'll use it for chilling water. Use it for making concrete.
Right.
So it's got many uses.
Yeah, that tank pushes it out to
That's right. That's right.
U.S. Foods. It pushes it actually all the way past our town hall to Glaxo.
That's right.
And goes through the industrial park. So yeah, it's just a good resource.
Absolutely.
To have
And I'm
here.
sure we'll talk about that some more. Absolutely.
Yeah, a little bit. But anyway, basically, we're at this concrete structure behind us is the head of the plant. In other words, Zebulon is that way.
That's right.
And the effluent is coming down and feeding into what?
That's right. Well, we're actually changing the flow pattern of the plant. Currently, the flow pattern is for the influent to flow into the headworks and be pumped. We remove the screenings, we remove the grit, and then we go into the treatment units. One of the things we're changing about the plant is that we're going to equalize the flow. Okay, so equalizing the flow through the plant means that we're going to treat the water on a constant rate basis.
Right.
Okay, so say right now, we'll have minimum flow and we'll have maximum flow throughout the day. It'll vary. So during the really early morning hours, 3-4 o'clock in the morning, flow is going to drop down really low because people just aren't using the water in their homes.
Right.
But in the daytime, in the morning, folks get up, they're getting their showers, they're getting going, they use more water, and then throughout the day.
Right.
And so the flows then pick up at the plant.
Right.
There's some lag time, but it picks up at the plant. And what we want to be able to do is be able to treat through the plant the same flow 24 hours a day.
Right.
That's one of the benefits of the EQ basin.
Okay, so the equalization basin is what that is. Traps the water and then lets it flow out at a steady rate.
That's right.
So the EQ basin will raise and lower, but the flow through the plant remains stable.
That's exactly correct.
I know I'm saying the same thing over and over.
It's
but
okay.
It doesn't hurt to. I'll put it in common terms. But anyway, that's what it is. Now, how big is that?
That basin is 1.7 million gallons.
Right.
So it also gives us another benefit. Okay, so on a daily basis, you can use it for that flow equalization like we talked about. But in this part of the country, we're also susceptible to severe storms, hurricanes. And when we get that kind of rain from those type of events, there's so much water that gets into the sewer collection system from a rain event that you really need to have a place to divert that rainwater so that you can treat all the water that still comes into the plant. And so the equalization basin also gives us the ability to store water and treat it as we can, and not to overwhelm the rest of the treatment process.
Well, here recently there was a lot of work going on in town, and they were relining the pipes, and a lot of that, correct me if I'm wrong, was done to stop the I&I, or the infiltration of water that makes its way in there that's not supposed to.
Absolutely.
There might be cracks in the pipe or whatever.
That's right.
So hopefully that's going to be minimized, but you still are going to have some, no matter how.
Oh, that's right. I mean, if you think about it, the piping network, you're right. We've done a lot of work to try to tighten that up and to stop areas where water flowed freely into the sewer collection system. You're still going to have small cracks, the joints where water forces its way in because it's a lower pressure inside the pipe. But what what you can't necessarily stop is you see manhole covers in the street, right? Manhole covers will generally have vent holes in them. Water's going to run in. You can't stop it. So we'll still see an increase in flow during a rain event, but if we can reduce that any amount, it helps the treatment process.
Well, I know in the old days they even had gutters and downspouts connected to the.
That's right.
We
That's right.
stopped that now. But anyway, okay. Well, let's get back to where we are. Okay, it comes into the equalization basin.
That's right.
And that stabilizes the flow. Where does it go from there?
Well, after the equalization basin, we actually have one important area that we have to cover before it goes into the equalization basin. Okay. Very first step when it comes into the plant is going to be pumping. Okay, so we're going to come into the treatment plant, and then it's going to get pumped. But actually, before we even pump it, you're going to have a screening process. So the water has to pass through this really tight mesh, and it basically traps and removes any kind of paper or plastic or woody debris, things that don't break down in the treatment process.
Is that contained, or is that something we could see?
Oh yeah, we can see that.
Well, let's go look at it.
Okay, let's do it.
Yeah. All right, so we're at strainer. Is that what you call it?
Well, we call this the Influent Bar Screen.
Okay.
Influent Bar Screen is a mechanical device that basically strains the plastic and the paper materials out of the wastewater.
Right.
So it's the very first step, and we have to do this to protect the equipment downstream. You see, there's no point in allowing plastics and wood and different things that end up getting into the sewer collection
Right,
system
right.
to go into the treatment plant where we can't break those things down anyway.
Right.
So we take them out right at the beginning, get them into a dumpster, and they'll go off to the landfill.
Okay.
And they'll break down in the landfill like they're supposed to.
Okay, all right.
Okay.
What are we looking at here?
Well, what you see, that is the actual bar screen, and that coil that you see is actually what carries is the electric cable. It's the conduit, if you will, for the electrical cable that goes to the electric motor up there.
Okay.
And what that thing will do is it'll actually go down into the water, it'll dip, and then pick the screenings, whatever's trapped against those bars,
Right.
it'll pick it, pull it up, and then send it into the dumpster.
Okay.
And so it's just a mechanical
So
device.
this is the dumpster behind us here that it ends up in, is that correct?
That's right, that's right. In fact, I could probably even make that thing come on if you want to see what it looks like.
Well, I just noticed the dumpster here, so
Sure.
it pulls it up, brings it over, and puts it here.
That's right. We also, the grid, well, what happens here is it's, one of the things we're doing in this upgrade is going to be, is to more automate this process.
Right.
As you can see, there's actually, this is done manually. So,
I see. Right.
it dumps it into this, this small wheelbarrow-like thing.
Yeah.
And then that's manually dumped by one of our operators
I gotcha.
into the dumpster. After this upgrade is complete, that'll happen automatically.
Okay.
That'll automatically be conveyed into the dumpster. It'll also be compacted. So we squeeze any water out of it, and then that's less weight that you're hauling,
I'll follow you.
and it's less cost at the landfill.
Okay.
Bob, that's an example there of what the influent coming into the treatment plant looks like. I mean, it's still got some clarity to it, but it's very cloudy.
Right.
And if you look at it really close, you can see some fine solids in it.
Right.
You know, the wastewater really breaks down in terms of particle size as it
Right.
travels through the sewer collection
Right,
system.
right.
And like I said, that's what it looks like coming in.
Okay, here's where we start, and we'll show them where we end later on.
There you go.
Okay. All right, so where are we now?
Well, now we're on top of the aeration basin, okay?
Okay.
This is the activated sludge part of the treatment plant. And to be honest with you, I like to refer it as the heart and soul of the process.
Right.
The reason, if you look at the water, you can see that it's brown in color, okay?
Right.
What we just saw in the influent where it's first coming in, it's clear, it's cloudy.
Right.
It's dirty, it's got a lot of pollutants in it, but it doesn't look like this.
Right.
When it gets in here, it's got that brown color. That brown is what we call mixed liquor. And it's, or flock, we call it flock.
Right.
And what it actually is bacteria.
Right.
It's the bacteria that consume the waste in the wastewater.
I understand.
Okay, they consume it. They capture that carbon and they use it for reproduction and lots of different, and energy. So that's what we do really in the wastewater treatment process is we raise bugs or bacteria to consume the waste. And then we control where those bacteria go and what we do with them.
Right.
But as the water passes through this tank, it'll come out the back and it'll have, the pollutants will be consumed.
You know, I recall one time that somebody in town was using some type of cleaner or something that got in here that killed the bug. And, you know, that's why the people need to know that some of the industrial sites have to have pre-treatment before it ever comes here.
Absolutely, that's a great point.
To take some of those things out, because if you kill these bugs, then you got to reconstitute them and just crank the whole thing up. And,
absolutely correct, Bob. These bacteria are living creatures,
Right.
and they are susceptible to things that are toxic.
Right.
And a lot of industrial cleaners, chemicals are very toxic
Right.
and can kill the bacteria. If we kill these bacteria, we lose our ability to treat this wastewater.
Right. Let's say you lose them. How long does it take you to gear them back up?
Well, if you lose them completely, what you're going to have to do is call a neighboring wastewater facility and ask them to bring you some new ones. Because
Okay.
you're going to have to seed the plant. You're going to have to get some in there that can start reproducing.
Right.
But once you do that, you could still take you 2-3 weeks, a month,
Right.
depending on the weather conditions, to get those bacteria back where they need to be.
Okay.
Obviously, the warmer the weather, the better.
Now, let's jump to the other side.
Okay.
One of these units is running in the over here. Folks may be able to hear it in the background, but tell us what we're looking at right here.
Well, what that is what's called an aerator, okay? An aerator, keep in mind that there are different kinds of bacteria in these basins. And we use the aeration for mixing, to keep them all mixed up.
Right.
But we also use it because they're aerobic, or they like to consume oxygen.
Right.
All right?
Right.
They need oxygen to live, like we do. But there are some plants of these tanks, like for example here, where these aerators are off.
Right.
And where they're off, we're actually stimulating the bacteria to take oxygen away from a nitrate molecule.
Right.
When they do that, it causes denitrification, and that's one of the ways we remove nitrogen from the wastewater.
Okay. All right. All right, so it goes through here, the bugs have their meal,
That's right.
and where do we go from there?
After here, we go on to secondary clarification. And secondary clarification is where we truly separate the bacteria from the clean water, and we return the bacteria back here to continue working.
Right.
And the clean water goes on to the next step after that, which will be filtration.
Well, let's take a quick look at that.
Let's go look at clarification.
Okay, so now we're at,
The secondary clarifier.
okay.
Okay. Secondary clarifier, what happens here, as you can see, is it's a very quiescent surface. It's a very quiescent tank. There's not a lot of activity going on.
Right.
We want it to be really calm so that the solids that you saw, those brown colored bacteria that you saw in the previous tank, we want them to slowly settle to the floor and form what we call a blanket on the floor.
Right.
Okay. You see those arms that are going around, they're rotating around really, really slow.
Right.
So not to disrupt that blanket. They don't want to stir it up.
Right.
But there are at the bottom of that arm is this mechanism that sucks up those solids.
Okay.
Okay. Like a straw. Picks them up off the floor and we pump them back into the previous tank. So we recycle the bacteria.
Right.
Okay. Now the water on the top, you can see that there's water coming over these weirs.
Right.
The water coming over these weirs is, as you can see, it looks an awful lot cleaner than what it did in the previous step.
Yeah.
It's now been, the bacteria have been removed for the most part, and it's one step cleaner. We've treated it biologically through an activated sludge process, and then the next step for this water is to go on to filtration, where we will remove any fine solids that might be left in that water.
Okay, well, let's move on then and take a look at filtration.
Okay. We're in the filter structure. This filter structure was covered in 2004 because we were having problems with algae growing on the surface of the sand medium. What would happen was that sand or the algae would grow on the surface. The water or the sunlight would penetrate the water, cause that algae to grow like crazy, and it would affect the performance of the filter. It would actually cause it to blind or foul and back up.
Okay, so is it a sand filter or is it a membrane filter?
It's a sand filter.
Okay.
It is a sand filter. There's, just millions of particles of sand here of a uniform size, and the water has to travel down through that sand. And as it travels through, if there's any fine particles in the water, the sand, it gets trapped in the sand.
And how often do you have to clean that sand out?
Well, it just depends on the water quality coming in.
Right.
So what we have is, this is called a traveling bridge filter. And you can see down there that there's a bridge and a rail system, much like you'd see on a railroad track.
Right.
And what happens is when that water level gets to a certain height, that tells the bridge that it needs to turn on and start cleaning the sand.
Okay.
So, because it's getting blocked up.
I understand. Right.
It's just that simple.
Okay, and then from here it goes.
Actually, there's only one more treatment step after this, and it's disinfection. The water coming out of this filter is pure. It's very clean.
Okay.
And it's ready to just be disinfected. Disinfection can happen with ultraviolet light, it can happen with chlorine, it can happen with ozone. Lots of different methods of disinfection. But we're going to see UV disinfection.
Let's go do that.
Right.
Thank you. All right. Well, TJ, we're at the disinfectant station. I guess that's what you call it.
That's right. We call this the UV structure.
Okay.
This is the final treatment stage in the treatment process.
Right.
Once the water goes through here, it's been disinfected, which means we've killed the bacteria that could be harmful to people. Right. So that's the last step, is make sure what gets discharged back into Little Creek is clean and safe.
Right. And a lot of people may not know, by the way, that Little Creek feeds into Moccasin Creek, which goes down to Taylor's Mill, which eventually goes into
the Neuse River. That's right.
So, it goes on its merry way. But part of it recycles back through our reclaimed water system as well.
That's right.
And most of that ends up and comes back through the plant again after it's used.
It does. Well,
except for the irrigation.
That's right. Well, or the concrete.
Yeah.
Any water that goes into making concrete or goes into irrigation, that water's gone from here.
Right.
Right. But any water that goes into the chiller systems or cooling systems of some sort, that water is ultimately going to be recycled and come back.
I've had people be concerned about reclaimed water and the clarity of it or the purity of it. First of all, let's say this is the product.
That's right.
that the final product.
That's right.
And you can see that it's a whole lot different from what we saw on the other end.
That's right, that's right. So you saw the very first stage, it was very cloudy, kind of grayish color. The second stage, we're in the aeration basin, it was very brown. It had lots of bacteria in it that was doing its work. Now we've removed all of that, and that's the final product. And folks, if you can't see that on camera, I will say that you cannot tell the difference between that and drinking water.
Yeah. Well, I'm not going to be like Avery Upchurch and drink it, but for those that don't recall that, Avery Upchurch, former Mayor Briley, drank some of the water that came off one of the waste treatment plants up there. I'm not going to follow in his footsteps on that, but nonetheless, it is very clean, and it is pure.
We certainly wouldn't expect you to drink it.
I understand
but
that.
I think it's a testament to the treatment, the technology of wastewater treatment today. Wastewater treatment is extremely advanced. And I don't think that people should fear wastewater. The rules and regulations that govern this industry are very stringent in terms of protecting the environment and public health. And I would venture to say that anybody who's drank water from any source has that water has probably been through a wastewater plant at one point.
Well, one of the current things on water use today is to thinking about going and pumping it back to the headwaters and then reusing it through the potable system again by treating it as potable water and then disseminating it out in the system. But if you think about it, Durham puts water in that goes into falls. Creedmoor does, and we use it. We send it on its merry way, and it goes down. And Smithfield uses it. Smithfield, Selma, one of them or both of them. Goldsboro, Kinston, Newbern, all the way to the coast.
That's right.
So it is constantly
water is recycled over and over again.
Over. So if there are any fears of this being unsafe, I think those fears can be put aside.
I sure hope so.
Right. Okay. Now we are, as Brian said, at the dirty end.
That's right.
This is biosolids.
That's right. The biosolids are an extremely important part of wastewater treatment. Okay. Our primary job is to clean water. Right. And that's what we do. But we talked about in the earlier treatment process that we use bacteria to do that. Okay. Right. Well, the bacteria we can't just discharge. We can't discharge those bacteria. We have to send them for further treatment and convert them to a fertilizer so that we can get some beneficial use out of them.
Right.
They've eaten a lot of the pollutants that are in the wastewater, but a lot of those pollutants are things like nitrogen and phosphorus.
Right.
Okay. Nitrogen and phosphorus are key elements in any fertilizer. So that's what we're able to use the biosolids for. Biosolids make an excellent fertilizer for crops that are fed to animals. They're a great crop for hay, for that sort of thing. So, this wastewater treatment plant does a great job of treating water, and this particular treatment process is what we call aerobic digestion, where we use air, we provide air and let the bugs break down further and further. And the way they do that is it's a cannibalistic process. The bugs actually eat each other. And so if you have two bugs and one eats the other, how many do you have left? You got one. They just cut themselves in half.
Right.
So that process happens over and over
Well,
again.
is this goes to the land application in fertilizer. Does it go in its liquid state or is it dried down to a solid state?
Well, what we do inside of this tank is we'll turn these aerators off. That aerator is providing mixing and air to this tank.
Right.
So when we'll cycle those. We'll turn them off. We'll let the solids settle to the bottom, and we'll draw the water off the top, send it back to the head of the plant for treatment.
Right.
And doing that over and over again is a process called thickening.
Right.
So we'll actually haul this out of here as a liquid that's about 3% solids.
Right.
Okay. Still 97% water, but about 3% solids. Now, when you see something that's 3% solids, it's pretty thick, actually.
Yeah.
It's about like a milkshake in consistency.
Right.
Okay.
Okay, a biosolid milkshake then.
A biosoliid milkshake. Chocolate milkshake.
All right, but this is, it's the final process we showed earlier, but this is where the waste of the waste treatment facility meets its final use.
And Mr. Mayor, we have all kinds of plans for biosolids in Raleigh.
Right.
We've got 3 wastewater plants.
Right.
This is one of 3. We ultimately have a plan to capture the energy that's stored in these biosolids. There's a treatment process called anaerobic digestion.
Right.
And what our intent is to take all of the biosolids, send it into anaerobic digestion, produce electricity we'll generate methane.
Right.
The methane will burn in a generator. We'll produce
Right.
electricity,
Right.
able to sell that back to the grid, or just offset our own use and not be as much of a drain on the grid.
And I know that some waste treatment plants actually dry it down and bag it and sell it as fertilizer. I think Chicago is one of the ones that does that.
Milwaukee has a product
yeah.
they call Milorganite.
Yeah.
But the wastewater treatment plant, the Neuse River wastewater treatment plant, Raleigh's larger plant, also has a process of drying. We have dewatering facilities
Right.
where we'll dry it down to where it looks like dirt.
Right.
We'll add lime to it so that it's got a high pH, and we sell that to farmers
Right.
for soil amendment on their farm fields.
Yeah.
So there's all kinds of beneficial
Yeah.
uses for this biosolids product.
Recycling at its best.
That's exactly right.
All right.
We do that from start to finish.
I got you. Well, let's go take a look at the lab.
All right.
Well, TJ, we're in the lab now, and I guess this effluent is tested all the way through the process. People can see there's an abundance of beakers and
That's right. But laboratory equipment. This is a
Right.
lab. It's a laboratory that's it's a bit under construction right now.
Yeah.
But what's happening in here is we're monitoring the process from start to finish.
Right.
Okay, that's the most important thing that happens here, is that we're checking the pHs, we're checking alkalinities, we're checking DO levels, we're checking ammonia levels. We're checking fecal coliform in the effluent. So there's a lot of tests that are done here just for process control, just
Right.
to make sure
Right.
that all of the parameters are being met in each of the different
Right.
treatment units. There is another laboratory that the city owns that's at the Neuse River wastewater plant. That's our compliance laboratory.
Right.
And most of our compliance sampling is done there. So samples are collected here every day and are shipped off to the compliance laboratory at the Neuse River plant. But all of that laboratory testing is just to be sure that the water that we're treating has been treated to the quality that it needs to be treated to. It meets all of the regulations, and it's safe to be discharged.
Well, people can see there used to be a window here.
That's
There's
right.
construction on the other side. Is that just an extension of the lab, or is what else is
Well,
what's gonna
it's,
be
no,
on
it's not really an extension of the lab. It's actually adding a conference room. It's adding a room for our operators on. It's really just adding some facilities that we've needed at this plant for
This
quite some time.
administrative space?
It's mostly
Yeah.
administrative
Right.
space. That's
Okay.
right.
Well, I think we've about covered it, and I really want to thank you for the time you've given to show us around the plant. I hope the folks have found this interesting. Again, I hope you found it useful, and look forward to seeing you next month.
It is certainly my pleasure. Thank you.